All right, we're going to take a look at calculating formula mass for ionic compounds. Similar to covalent, when you do the mass, you would multiply by how many are there. But with these, we don't have prefixes. So remember, ionic compounds don't have prefixes in the name. They list the metal first, then non-metal drops the ending, and you add IDE. So if we have something like lithium fluoride, lithium is in group 1, fluoride in group 7. So lithium has a charge of +1, and fluoride has a charge of -1. So if you add the charges together, +1 and -1, we get 0. So we just need 1 lithium and 1 fluoride. When we're doing the math for that, you would add the mass of lithium. So there's 1 lithium, 1 times 7, plus 1 fluoride, which has a mass of 19. And we get the mass from the molar mass or atomic mass on the periodic table, the bottom number, and you round to the nearest whole number. Our next one here, we have beryllium oxide. So we would have beryllium, which is in group 2, and oxide in group 6. So we have +2, -2. Those are also the same, so there would be 1 of each of those. Beryllium has a charge, or a mass of 9. Oxygen has a mass of 16. And then you would find out what they were equal to by multiplying and then adding them together. This one's going to be a little different. Potassium nitride. So potassium is in group 1. Nitride is in group 5 or 15. So it would have a charge of -3. These charges are not the same. So what we're going to do is we're going to add them until we get to equal 0. So +1 and -3, if you add those two numbers together, you get a total of -2. So we have more negatives than positives. So we're going to add another positive. So now we have +2, -3. Now our total is -1, so it's not quite 0. So let's add another positive and see if we get there. So now we have 1, 2, 3 positive, 3 negative. So now our total is 0. We're going to go ahead and count and see how many there are. So we have 1, 2, 3 potassium. So we're going to do K, control comma 3, control comma O. That's 3 potassium and 1 oxygen. So you do 3 times the mass of potassium plus the mass of oxygen. So for that, if we did 3 times 39, that would equal 117. And you're going to add 16 to that. So our total mass for this ionic compound of potassium nitride is 133 grams. And you'll continue that. This one is a little different. Chromium 3 oxide. So this 3 for our transition metal gives us the charge. So that means chromium, and since we know it's a metal, it's going to be a cation, so positive. +3. Oxide is group 6, -2. So what we're going to do, we have to get these equal. Right now we have +3 -2. Our total would be +1. And we want it to be neutral here. So we're going to add a negative and see where that gets us. And you can't just say oxygen -1. It has to be the charge that one has. That's how many oxygen needs to gain, and +3 is how many chromium is going to lose or give away. So we add an oxygen. We have +3 now, and -2, 4. So if we have 3 minus 4, that's going to be -1. That's not balanced. So we needed to find a way. So now we need more positives. Chromium +3. So now we have 6 minus 4. Now we have a +2. So we still need to add some more. So let's add another negative. And if we have +3, that's +6 minus 6. That'll get us to 0. So now we're going to go add up how many we have. So we have 2 chromiums, 2 chromium ions, because we look at how many, not the charge. The charge just tells us how we can get them to equal 0, or transfer the right amount of electrons. Oxygen, we have 1, 2, 3. Again, not looking at the charges now, we're looking at the quantity. So 3 oxygen. And then you go ahead and do the mass. 2 times whatever chromium is plus 3 times whatever oxygen is equals our compound mass in grams. And you'll continue that the rest of the way down. These 3 are just some examples of what you can do. These involve some polyatomic ions, but they just show some examples of how you would calculate these different ions down below.